All right, guys, here we go. Okay, a couple of things.
Hello. I'm sorry. I'll try to be better.
First of all, I hope everybody enjoyed the long weekend. Let me tell you how I enjoyed the long weekend. After class on Friday, I spent 4 hours at urgent care in Snowmass to be diagnosed with the fact that I had the flu the week before, and then had developed a subsequent pulmonary infection that led to pneumonia, which I'm currently being treated for. So I've been on the antibiotics now. This is the 4th day, so I'm no threat to anyone here. However, we're going to start doing things a little different in this classroom because it is just ridiculous the way that we spread all of this crap that you kids drag into these doors every single day. And when I say you kids, I realize, us old people drag it in too. So here's what we're going to start doing from now on. See that sink over there? We're going to wash in, we're going to wash out. Tomorrow, I will have those disinfectant wipes, and we're going to use them like we did before I ran out of the darn things. Then this, I hear somebody cough, guess what? You're going on cough protocols. You're going on cough protocols. Stephanie, thank you so much for modeling the latest in sanitary fashion. I appreciate that. So we're going to wear them, and I'm done. I'm not playing anymore. I mean, we've got to start doing this. We have to think about this. Because again, if you look at the number of days that people wind up missing school because of the fact that we're sick, and then again, I mean, seriously, how many of you, just quick show of hands, how many of you been sick lately? Questions? So, I mean, it's just, this is the thing. Guys, if you're coughing, if you feel like you've got something even coming on, that's the worst time to spread infections. That's when I have these here. And what I don't want to do is I don't want to say, easy, put one of these on. They're here. You come in, you're not feeling right, pop one on, okay? You've got to think of the rest of us. Does that make sense? And I don't want to sound like a hard butt because I'm going to do the same thing. I'm not going to hold you guys to anything else that I won't hold myself to. But we really have to start thinking about this, guys. We really do. This flu stuff that's going around, they're not playing. People are dying, okay? And I mean, it's kind of a thing. And so we really need to start thinking about this. And you need to be thinking about the fact that you walk around hacking, coughing, oh, I covered my mouth. Is that covering your mouth? Seriously, no. This is covering your mouth, okay? We have to stop being a little as selfish as we have been before. And we have to start thinking about ourselves and others. Here's how we start. Guys, does that make sense? And I cannot possibly be any more serious than I am right now. I'm just having spent 4 days freaking horizontal here. It's just like, horrible. And again, I take responsibility for this as well. Last Tuesday, I should not have been here. Wednesday, I shouldn't have been here. I didn't have a choice. I didn't have anybody to cover the class. Otherwise, I shouldn't have been here on Wednesday. And if I was, I should have been wearing one of these. So, this is my promise. Not just to you, but from you. Questions? Consider this a badge of honor, okay? That you're taking responsibility for yourself and others. There we go. Okay. Enough of that. Now, Olympics. Taryn. Who else? Alex? Alex there. Did you guys watch them a little bit last night? I stayed up so I could watch.
Yeah.
It's going to be kind of fun. I think that's going to be awesome. Go Aspen and Basalt. Okay. All right, there we go. All right, where did we stop on our true course, magnetic variation, and magnetic course? Where did we stop?
It was one of the 1v8s. Yeah, it was 1v8 to KANK.
Okay, 1 Victor 8 to KANK. 1 Victor 8 is what?
Leech. Yeah.
Okay, all right. So 1 Victor 8. I'm plugging this in here, guys. Stand by. Oops. Come here. Shoot. Hang on.
I didn't. Somebody else did. What's K and K? Four corners. No, just kidding.
Nope.
That was like Alex.
K-A and K.
Sorry, I was looking at the wrong one.
Salida, right? Hold on. All right, what'd you guys get? Table number 1 here. What'd you get for your true course?
North, so 360 or 0 degrees. Oh wait, no, general direction, sorry.
I was going to say your general direction of flight might have been north.
Yeah, oh, sorry, I said no direction of flight.
Okay.
0, 0, 0, 0, 0. You have to say that in that situation?
What?
0, 0, 0.
Or 360 or north. What are you saying? Just general direction of flight?
Do you have to use say all 3 numbers, even when it's 0? So our true course was 0, so we say true course.
Your true course could not have been 0. It could not have been 0. Take a look at your maps. Take a look at your maps. When you have an airport on one side of a line of longitude and another airport on the other side of the line of longitude, your true course cannot be 0.
Oh, okay.
Take a look at it. Whip them out. Do you guys have a map? Tate, do you have a map? Tate, look on here with the guys in the back there.
Oh yeah, right here.
Look at 1 Victor 8.
Yes.
1 Victor 8 and K-A-N-K. Okay, on this one, guys, I'm lying to you. I was thinking Santa Fe to K-A-L-S. I was on the wrong line. You guys are, this should be correct. This should be 000 or 360. Forgive me. Okay, this is it. So then, what did you wind up for then with this for your magnetic course?
300. Is it 300? 361? 351.
351.
351, yeah.
351. Why do you get from 360 or 000, how do you get 351? Tell me how that works. Okay, because the closest line of magnetic variation is, guys, you got to be looking at a map. Where's your, all right, which one's next?
Leach to Alexander. No, that's sorry, Alexander to the Four Corners.
Okay. So from this one, K-A-N-K to K-F-M-N.
Yes.
All right, what'd you get?
True course 224. The closest magnetic variation is 9. So the magnetic course becomes 326 with a distance of 117 nautical miles. I think we got our true courses 224 and our magnetic course. Oh, I wrote this down in the wrong spot. Just kidding. That was all for something else.
Okay, you're pretty good right there. Table number 1 has just about got it.
KALS to KASE.
Okay, all right, there we go. There we go. All right, you guys see that? So from there, your magnetic course should be about 216, probably 215. Maybe I don't have that on there quite right. So if I go here, there's 216, 217, 216, showing 216, and showing a distance there of 149.3 nautical miles. So that's going to be your magnetic, that's going to be right here, your magnetic course. Okay? You guys got that? Everybody got it?
Yeah.
Okay, next. What's next?
KFMN to KSAF. Is that all right?
Yeah, that's right.
Where is, so from Farmington to where? Santa Fe. Okay. All right, so what'd you get for your true course? Tree 5, really.
I got
What's your general direction of flight?
west, southwest.
What's your general direction of flight? Southeast. So what's your general heading?
135.
Somewhere around 135 for southeast. Okay? So you know you need something along those lines, correct? Okay?
I think I did this one backwards. I did the
Is
from is
it-
the 2 and then 2 is
Okay, yeah.
1, 2, 1.
Distance 1, 2, 3.
Okay? So, what is your true course here, guys? What's your true course?
1, 2, 4.
What's your true course? One, two, two? What'd you guys get?
1, 2, 4.
I got 1, 2, 1.
Okay, it's pretty close. It's pretty close. What's your magnetic variation? What are you going to use there?
9.
Probably use 9. So what'd you get for your magnetic course?
1, 1, 2. Yeah, 1, 1, 2.
112. This is showing 113.
What's in southern hemisphere? But that's not.
Okay,
1, 1, 3. Yeah, I got 1, 1.
okay. You see this? Two-finger method, from and to. Right? General direction of flight is the first thing you write down. And then a corresponding general heading that goes along with that corresponding general direction of flight. That way you do not wind up flying backwards or flying out to sea. Okay? Distance, what'd you get?
1, 2, 4.
About 123 nautical miles. 123 nautical miles. Next. KSAF to KLAS, is that correct? Or ALS, is that right? No?
It's there, right?
All right. Now, take a look at this. This is the one that I was talking about earlier, guys. And forgive me on that first one. Whenever you're crossing a line of longitude, you know that you're not going to be anywhere near 0 on something here. So what is going to be your true course on this? What'd you get? Negative. 006. 006. That is going to be your true course on this. Here, don't just trust me. Lay your plotters out there, and let's take a look at it.
It's okay.
True course. From Santa Fe to Alamosa. Santa Fe to Alamosa. Lay your plotters out there. Find out how you get 006. You should have your lines on your maps.
Right here.
So if you got a line crossing, you just get the line
Right
and
here.
with this, and then measure it.
Where's your line?
I don't have a line on this one.
Let's get a line. Easy. Hand me one of those meter sticks, please. Thank you. Let's go.
Right, yeah, there.
Hold on. Okay. Okay, there's your line. Now, here we go. This is your line, correct? Okay, we're going to put that right there on that line where your grommet is right there.
And you see that as
Take a look right there. See this? See how you're off? 6 degrees? Okay, so 0, 0, 6.
okay. Yeah.
This is the one we did with everyone.
KSA after KAL.
Did you guys figure out the error of your ways? Table number 1. Did you figure it out? Okay.
Do you guys still do you get 9 still for your magnetic variation? Do you still use 9?
9 looks like the closest to me.
Okay.
Is this the magnetic variation line?
Yes. That's your closest isogonic line. Your closest isogonic line is going to give you your magnetic variation.
Does that change?
What do you mean?
Doesn't it have to be changed on maps every 3 years?
Take a look at the front of your sectional maps. Every 6 months.
Oh, geez.
Every 6 months. It changes, technically it changes every day,
Yeah.
but
How much does it change every 6 months?
enough. It'll change by several miles. All right, next. Oh, what was the distance?
112.
I got 109.
109, yeah.
Wait, I just realized what
How'd
happened.
you do that?
Well, the first thing you have to do is like check your plotter against your
Next. What's next? KALS2? KALS2, what?
KSE.
Back home.
This is the one I previously read to you.
Okay.
I read this one.
All right. General direction of flight?
338 northwest.
Kind of northwest. 315-ish. That'll get us started. Could be north-northwest, you know, possibly. So as long as we know that we're just kind of flying kind of north-northwest somewhere through here, okay? What'd you get for your true course?
335.
335. Does that make sense? Is that what you got? Okay. Then your magnetic variation, what'd you use?
9.
Okay, so that gives you what then?
326.
326?
Yeah.
Everybody good with that? Distance?
117.
Okay, 117 is correct. Now, hang on to these results because we're going to use these in our next exercise. So what you have here is, I just want to again reiterate what it is that we're doing here. We're using a sectional map. We're converting a straight line on a map, which is going to give us what? A straight line on a map, first of all, gives us, well, that gives us our true course. Our true course. Then we make an adjustment based on what? Magnetic variation, okay, to give us a magnetic course. That line on that map, that's our course line. And from that line, once we start making these cross-country flights, you're going to be looking outside the airplane, and you're going to be identifying some of the features of the terrain, some of the mountains, some of the roads, some of the rivers, lakes, towns, to help make sure that you're where you think you are. Pilotage, that's what that is, looking outside the airplane. There's supposed to be a lake over here to my 2 o'clock. Up, there it is. Excellent. I'm pretty close to being on course. There's supposed to be a mountain right over here, 14,141 feet. Passing it now off my left wingtip, still on course. Okay, that's the stuff that we do when we look outside the airplane. Then we go from that pilotage piece to the dead reckoning piece. Flying a particular heading at a particular speed for a particular time is the dead reckoning part of what we do. time, speed, and distance. But in order to do that, we have to think about being in the real world. What is absent from these calculations that you have been doing? Wind. Wind. So how will wind affect us?
You might need to pitch at
Blow you off your course.
Okay? It can, without an adjustment, take you away from your course. How far?
Far depends on how,
What does it depend
how
on?
strong the wind
it
is.
depends on how far you're flying and it depends on how
And
strong.
how long it takes you to recognize it?
So how long the wind is blowing for?
Depends on, first of all,
Direction in relation
depends-
to the direction you're going.
so it depends on direction. We've got that. So direction is one.
Speed.
Wind velocity is another. What about the speed of your airplane? The longer you're exposed to that wind, the more off course you're going to be, correct?
So if you're going slow.
So the faster you are, the smaller the correction that you'd have to make. The slower you're going, you're going to have to make a larger correction, right?
It's like if it's 1 degree over.
So if you look at this and you think, okay, how then are we going to be able to estimate what we call the WCA, wind correction angle? So with that, that is where we begin using our E6B flight computers. So, how many of you have them with you today? Is there one at each table, at least?
We have one at this table.
Where's the rest of it?
This.
Yeah. Yeah. Better put it back together. Okay. Now, let's take a look at the E6B. First of all, what is an E6B? What is it?
A flight computer.
A flight computer. Okay?
It's supposed to go.
So what is it that this computer is going to compute? Flight stuff. Excellent.
Wind?
Our wind
Wind is going to be part of it.
Time, speed, distance, fuel consumption, and make conversions
gives us
between
our-
measurements.
airspeed correction, our altitude correction, and our wind correction.
Now, there's two sides. First of all, when we look at this side, we have the calculator side, and then we have our wind calculator side. The first side we're going to look at is this side, is just for general computations. I want you to notice this. There are 3 rings on this E6B flight computer, and we're going to label these rings. The outermost ring is the alpha ring. The center ring is the Bravo ring. The innermost ring is the Charlie ring. Please tell me you're taking notes. Alpha, Bravo, Charlie. All right? Now then, let's take a look at how this is set up. If you match the 10 on the Alpha to the 10 on the Bravo, you notice that all the numbers kind of line up, right? Did you notice that? But you've also noticed that there's something else that you can do, and that is you can actually spin this portion of your flight computer. The little black arrow or black triangle, that is called your index mark. That is your index mark.
What's the index mark?
The black triangle.
That's 60.
Now then, let's put the black index mark at 60. On your E6Bs, put your black index mark at 60. I was going to say, you might want to put that where other people at your table can see. And by the way, guys, from now on, you're standing right in front of the camera. from now on, bring everything, okay? Because from this point on through the rest of the course, bring everything. How many of you are driving already? Okay, some driving, okay? So let me ask you a question. Let's say that you're driving and your rate of speed happens to be 60 miles per hour. So in 1 hour or 60 minutes, you're going to go 60 miles. How many miles per minute are you going? 1 mile per minute, correct? Okay. Now let's say that you live in Germany and you're on the Autobahn out there, and your rate of speed is 120 miles per hour. You have doubled your rate. How many miles per minute are you going now? 2. So in 30 seconds, how much distance should you travel? 1 mile. So at 120 knots, or miles per hour, how far will you go in 45 minutes? Don't look at the computer. Don't look at the computer. Use this computer. How far would you go at 60 in 45 minutes? At 60, if your rate is 60 miles per hour, you'd go 45 miles in 45 minutes. So you doubled it, so it's 90, right? Okay? You kind of get where I'm going here with this? What am I using to solve these problems?
Reasoning.
Kind of reasoning, but I'm using ratios. I'm using ratios. Take a look now at the face of that E6B. What are we using there? We're using ratios. That's how we're solving these problems. That's what a slide rule is. This is a circular slide rule. This was technology before people knew it was technology. So that's how we're going to use these E6Bs, is to help us solve these problems. Now, Tyler, in that plastic binder that you got another little thing, another little guide at the beginning of that. Hold that up for everyone. Okay? Do you guys see that? In red letters it says E6B, and in great big bold black letters below it, it says what? Instructions. Ah! Can anyone guess what your homework assignment is tonight? Okay? Tonight, you will read your instructions to understand how to operate your E6B flight computer. Tomorrow, we will review. Then, I am going to give you another homework assignment based on the one that you just finished. In other words, I'm going to assign you a wind. And for every single one of those true course magnetic variation and magnetic course problems, you are going to have to tell me what your magnetic heading is going to be in order for you to reach your destination. Not only that, but you're going to tell me how long it's going to take you.
Sounds like a plan.
Wait, that's gonna be our homework from tomorrow though, right? The read is on tonight.
What's your homework tonight, kids?
Read the instructions.
Read the instructions, learn how to operate your E6B. Those were my words. Tomorrow morning we will review, and then we are going to apply our newfound skills to the assignment that we just did. Okay? Friday, quiz. Friday, quiz. That's going to be on your chart supplement guides, or AFDs, and it is also going to be on your computational prowess of the infancy of your new cross-country flight planning skills.
This is not gonna be, Mr. This is gonna be on paper, correct?
This one will be on paper,
When are you leaving?
probably Wednesday, after class tomorrow. paper. This will not be on prepware. This is going to be local knowledge. Prepware does not do enough to test you on the use of the E6B in cross-country problems. Not yet.
Like, get one of those little rooms at the library and lay out these maps.
Okay. Does everyone have the tools that you need to make this happen?
Yes.
All right. Off you go. Questions? Questions, anyone?
What? I'm still wearing it.
I know, and that's why you're wearing it.
Oh, yeah.
All right, guys.
Literally